Why did the Big Bang happen? When I think about life and the universe, I start with a simple question. Life is the result of a problem of energy transmission. Simply put, energy is the first element that gave birth to everything in this universe. But where did the energy come from? To answer this question, we have to go back to an important event in the history of the universe, the Big Bang. The Big Bang and the origin of energy. Many people will say that energy came from the Big Bang. Okay, but before that, I continue to ask myself, why did it happen? In other words, what was the reason for the energy to explode and create the universe we live in? When I studied energy, I noticed an important characteristic of it. Energy is dispersive. It spreads out in a V-shape, like when you turn on a flashlight in the dark, the light will spread out and then fade away. When energy is so dispersed, how can it create an explosion? To understand this, we need to better understand how energy works in the universe. Energy and magnetism theory. Energy does not simply disperse indefinitely. If it did, the universe would not have formed and developed as it does today. I believe that there is another factor involved in this process, which is the magnetic field. Magnetic fields have the ability to collect energy. If you imagine a ray of light passing through a converging lens, you will see the energy from the light concentrated into a single point. Similarly, magnetic fields can collect energy and create the formation of galaxies, gravity, and even black holes. Magnetic fields and energy, visualizing an inflated ball. Imagine our Earth as an inflated ball. The skin of this ball is the magnetic field surrounding the Earth. This magnetic field is not something fixed or visible, but it is everywhere, creating a strong gravitational force that holds everything around the Earth, like the outer shell of an inflated balloon. Now, if we think of energy as a force, you can imagine it as a wave moving from one place to another. This energy force will find ways to move and radiate, just like light or radio waves radiate from their source. The process of gathering energy into a magnetic field. Next, you can imagine that when a beam of energy, like a light beam or some other form of energy, approaches a softball, something interesting happens. Instead of the energy radiating and spreading out, the softball, or magnetic field, acts like a funnel. This funnel will help collect the energy rays back inside, making it unable to escape but gathered and enter the ball, retaining and absorbing it. The beauty of this image is that the magnetic field is not only a shell around the Earth but also has the ability to direct, gather and focus energy in a way that other objects cannot. It is this funnel, created by the force of the magnetic field, that prevents the energy from being dispersed indefinitely but instead is guided and retained. The connection with the universe, magnetic fields and energy. This funnel does not only occur on Earth but can occur throughout the entire universe. We can imagine that the magnetic fields of planets, stars, or even black holes all act like large funnels that collect energy from the surroundings, making this energy not dissipate but can be concentrated, and sometimes create strange cosmic phenomena such as the formation of stars, galaxies, or even stellar explosions. Conclusion. Thus, the image of an inflated ball is actually a good way to describe how the magnetic field surrounding the Earth and its interaction with energy. The magnetic field not only surrounds as a protective shell but also acts as a funnel that collects and retains energy, helping to create important physical phenomena in the universe. This image helps to clarify how gravity and magnetic fields can affect the movement and concentration of energy, thereby explaining cosmic phenomena such as the formation of galaxies, stars, and black holes. Energy and the formation of the Sun. Another important question is, how did energy create such a huge explosion as the Big Bang, and how did the Sun form so powerfully? Although energy is dispersed, I believe that magnetic fields and other factors in the universe help to collect this energy in a controlled manner. This led to the formation of stars and galaxies. Scientists now also believe that there is a special type of energy, called dark energy, and there is a type of matter called dark matter. However, I believe that it is the magnetic field that is the important factor in collecting and controlling energy in the universe. Without magnetic fields, galaxies and cosmic phenomena would not be able to form. The connection between the universe and biological behavior. To further illustrate the similarities between the universe and human biological behavior, I would like to make a comparison. You can visualize sexual behavior between a man and a woman as a process of energy transmission. Just as energy moves in the universe, in sexual behavior, energy is also transferred from the outside to the inside, creating connection and life. This does not mean that sexual behavior is the decisive factor in the formation of the universe, but I want to point out that the basic principles of energy, magnetic fields, and connections between elements in the universe can be reproduced in our biological behavior. When energy from the outside penetrates the Earth's magnetic field, it can create changes in the physical structure, similar to the way energy is absorbed and transformed in biological processes. Conclusion: energy, magnetism, and the universe. Finally, I want to assert that the Big Bang was not just a release of energy from a fixed point, but a complex process that repeated previous explosions, involving the interaction of energy and magnetic fields. Magnetic fields not only help to collect energy, but are also important factors in the formation of galaxies, stars, and black holes. These forces, although very powerful, all originate from simple principles: energy and magnetism. I believe that the relationship between energy, magnetism, and the formation of the universe can explain many phenomena in the universe that we cannot yet fully explain. And in the future, as we study the universe, we may continue to discover new principles that help us better understand life and the universe.